Hey, what's up, nerds? Today we are starting the first lesson of Unit 3, which is finding the vertex of quadratics. As you can read on the screen, obviously I'm not trying to insult you. I know you can read. So what you're going to learn today is how to find the vertex of a parabola, and that's it. I'm going to show you a couple of different ways that you can do that because it's always good to know how to do a problem more than one way. Particularly if, the way that I like best isn't the way that you like best. And some problems it's just easier to use one way over another. So you want to just kind of know what tools are at your disposal, right? You don't want to try and take lug nuts off your car with a hammer. You want to use a lug nut taker offer, obviously. So let's start with some vocabulary that you guys need to know. Quadratic. Obviously, this is just another word for a parabola. The way you can tell it's a quadratic is it's a polynomial with degree 2. And degree might be another math word you need to know. Degree means highest exponent. Whoops, hang on, my pen doesn't work there. Highest exponent. So if you had like y equals x to the third minus 2x squared plus 4, this would be said to be degree 3 because the biggest exponent's a 3. Okay, so it's the largest exponent of the polynomial. It can only be a 2. If it's a 2, that means we have a quadratic, aka a parabola. A parabola. Okay. For a parabola, there's a special point on every single parabola that we call the vertex. And this is just a fancy word for either the minimum or the maximum. And you're going to say, Barton, how can it be two different things? The answer to that is because parabolas can flip upside down. So if you have a parabola like this, we're talking about the minimum right there. Whoops, min has an M, not an N. Or if we flipped it upside down, then we're talking about that maximum right there. Okay. So we're just talking about that fancy spot on parabolas. That's the vertex. And that is what you're learning to find today. Okay. The last vocab word you need to know is standard form. And I know your teachers, not your kids, you don't have kids. Your teachers have been harping on you about standard form since you were in like 3rd grade. But just in case, you were traumatized by Miss Brown, you're going to have to, I'll teach it to you again, just in case you didn't like your 3rd grade teacher. So standard form is when a polynomial is just put in descending order by degree. So if I have y equals x to the 5th minus x to the 7th minus x to the 3rd minus x squared, this is not standard form because this number is bigger than that number, so that term should go in front, right? So it would be written y equals negative x to the 7th plus x to the 5th minus x to the 3rd minus x squared. So now all of these numbers go from biggest to smallest. That's what the word descending means. Okay, so now you know all the words I'm going to say. Now let's see what I'm going to say about them. For standard form of a quadratic, it's written as y equals some kind of coefficient, x squared, plus some kind of coefficient, x, then a number by itself. And you can kind of think of the number by itself as x to the power of 0, since this x here has an invisible 1. So when we have it in standard form, obviously descending order for exponents. But what's important here is how we're going to talk about these coefficients right here. It's important that you know that the leading coefficient is a, the coefficient for the linear term, or the first power term, is b, and then the constant is c. And that's easy to remember because c is the first letter in constant, obviously. Just as an example, if we had y equals negative 2x squared minus 3x plus, what's your favorite number? 13, probably, if I had to guess. I bet the other half of you said 7. So in this case, a would be negative 2. It's just that leading coefficient. B would be negative 3. It's the coefficient of our linear term, or our first power term. And then our constant is positive 13. Is that easy? It's just you need to know that I'm going to say A is this number. You know that this number is A, this number is B, and this number is C. All right, let's go find some vertices because this vocabulary stuff is for the birds, right? I want to do math. I don't want to learn words. All right, so let's find the vertex of this parabola. And I'll, again, refer you back to the joke on the front of the slides. Look, Mr. Barton, it's right there. Ha ha ha, here it is. Right, yeah, obviously, kid, like, I set this up for you to feel smart. Keep that in mind, okay? There it is. There it is. And you're right. So what is that ordered pair? I don't know, Mr. Barton. 1, 1? You are correct. The vertex of this parabola is 1, 1. Wonderful. I'm so proud of us. Vertex, if I could just spell. And it's an ordered pair, right? It's a location on a graph, 1, 1. All right. Unfortunately, you're not always going to just have a pretty looking graph to look at. So let's back this up a little and talk about other ways we can find it if we're not given the graph. Hopefully, for every single problem in the future, someone is kind enough to give you the graph. If that's true, use the graph because it's as easy as it looks on a graph. You just look at it, there it is, and then you write down the ordered pair. Okay, so that's strategy 1. Let's talk about strategies. We just want to have different ways that we can find our vertex. Strategy 1 is graph it and just look at it and figure out where that point is. Okay. And now you're going to say, but Mr. Barton, what if I don't know how to graph? What if the mean old test writers only give me an equation? They tell me that the equation of this graph is y equals 2x squared minus 4x plus 3. Don't worry, I'll hold your hand. We're going to get through this together. There is luckily a second method for you to try and figure out what the vertex is if you only know the equation. Method 2 is calculate it. And I know you're all sharp kids. It hasn't gotten past you that there's a formula up here at the top of the page that I haven't talked about yet. So let's talk about it because we're going to use it to calculate where our vertex is. So this formula, notice it says x equals. This is only going to tell us the x component of our ordered pair for the vertex. But don't worry, I'll tell you how to get the y component later. So what this says is that the x component of our vertex, this number right here, how far over our vertex is, it's that. X equals negative b, I misspoke. I didn't, but here we go again. Let me try that again. Sorry, I'm not very good at words. X equals negative b over 2a. Now you're going to go, Barton, what are 2 and, not what's 2. I hope you know what 2 is. What are b and a? I'm BA. Watch your language, kids. But b and a are just referring to these coefficients we talked about one slide ago. Hopefully you remember that. It was probably 2 minutes ago. So b and a are just those two coefficients from our graph, or from our equation rather. So let's look at our equation. Now let's figure out what a, b, and c are. But Mr. Barton, I don't see a c in there. Okay, fine. We don't care about c, but it's 3. A is 2, and b is negative 4. You take the sign with the number. So a equals 2, b equals negative 4, and c equals 3. We don't care about c. Yeah, we don't care about c, but, you know, I'm a completionist. I got to get all the achievements and write them all down. So let's go calculate x for this one. We already know it's 1, Mr. Barton. Okay, well, don't spoil it for the rest of us. So x equals negative b. Well, b is negative 4. So don't make the classic high school kid mistake here and just be like, well, I already got a negative. This negative is part of the formula. We still need to put the negative from the number in too. So the way I'm going to do that is I'm going to put a parenthesis. I'm going to put negative 4. Kind of like I'm replacing the b with a set of parentheses and filling in the number. Over 2, and I'll fill in a the same way. A is 2. Mr. Barton, this looks really hard. It's not. Negative, negative 4. A negative and negative cancel out and become a positive. So this is 4 up top. And then you've known 2 times 2 probably since you were born. 2 times 2 is 4. And it's hard to mess up because 2 times 2 is the same thing as 2 plus 2, right? And now, because some of you weren't always in honors, you're going to try and leave it this way. This will get marked wrong. You need to reduce your fractions. X equals 1. But Mr. Barton, that's what I said at the beginning. X equals 1. We already know that. I know, kid. I told you not to ruin it for the rest of us. So X is 1. But Mr. Barton, you didn't tell us how to get Y yet. I know, kid. Would you let me finish? Alright, so now we have X, and you're going to harass me until I tell you how to get Y. But luckily, if you look at the formula we start with, Y is already right there all by itself. All you have to do is plug your X into this formula, and then simplify it. And unfortunately, I wasn't smart enough to try and do this ahead of time. But we know it's 1. Okay, so let's make sure it's 1. So we're going to just plug in the X value we got from our vertex formula into the equation that we're given, and then we'll get Y. So we have Y equals 2, where the X is. Put parentheses, plug in your number, bring down your squared. A lot of times kids forget this squared. Be careful with that. Minus 4 times, plug in your number again, plus 3. See, I told you the C mattered. Now we've got to simplify this as carefully as we can. So 1 squared is 1, times 2 is 2. Negative 4 times 1 is negative 4, and then bring down your plus 3. Right, and now we just add. So 2 minus 4 is negative 2, plus 3 is 1. And I know, you told me it was 1, and I didn't believe you, but there it is. Okay, so just to go over this one more time. If you can graph it and look at it, do that. That's the easiest way to find your vertex. It's way easier to look at pictures than it is to do math. But if you can't graph it and you have to calculate it because you have just a formula and your teacher's mean, then you want to start by finding A and B. You can forget about C. Plug those into this vertex formula to find X. So we go and get X. And then once you have X, plug that into the original formula to get your Y value. All right. So this is the easy kind of baby problem just to get us warmed up. Now, here's what your actual homework problems are going to look like. We have to go find the vertex in a word problem. Oh, I know, you hate word problems, but it's good for you, right? It's like exercise and eating your vegetables. It hurts and it sucks and it doesn't taste as good as Flaming Hot Cheetos, but at least our liver won't turn not yellow, red. Is that what color Flaming Hot Cheetos are? Red? Rojo? Yep. All right, so to find the vertex of this problem, let's read the problem first. The number of mosquitoes in Minneapolis, Minnesota, in millions, that's going to be important, so we're going to just write the word millions on our answer, of mosquitoes, as a function of rainfall in centimeters is modeled by this equation. So M is the number of mosquitoes in Minnesota, and X is how much rain we get. So it's negative X squared minus 10X plus 5. What is the maximum possible number of mosquitoes? So we're looking for number of mosquitoes. That's what this M is. That's the Y of this. The other thing we need to notice is that my pen is writing in black even though I have red. How weird. Okay, there we go, fixed. The next thing we need to notice is that this is a quadratic. And we know that because the biggest exponent is a 2. So what that means is that our graph is either going to look like this or like this. And we know it's going to be the second one because our leading coefficient is negative. That flips it over. We learned that in the transformations section. So we know our graph is going to look like this. So if my graph of mosquitoes is something like this, and we're looking for the maximum, this is a really fancy way for them to ask you, what's the vertex of that parabola? Because they're asking you for the Y value, the only way for us to find that is to use our formula X equals negative B over 2A. So we have to find the X and then use it to go and get our Y value. So they're asking you to get the vertex, but they're just asking you for the hardest part to get, so you have to get the whole thing anyway. I know, math teachers are just so mean, aren't they? How dare we make you have to do all the work? All right, so I mean, we have to do all the work, and I'm here to do it with you. So let's go ahead and do it. Here's our formula. We need to find A, B, and I'm going to find C because I like to, but you don't need it. So A, I just see a negative there, Mr. Barton. Very astute, children. What that means is we have a -1 coefficient. Anytime you don't see a number, it's an invisible one. So A is -1, B is -10, and C, just because I like it, is 5. Now we're going to plug these numbers into our formula. So we're going to have negative, B is -10, so make sure you have the double negative, because this one's part of the formula and this one's part of the number, over 2 times -1. All right, now we need to simplify this. So -10 is +10, and then 2 times -1 is -2, and then 10 divided by -2 is -5. All right, now we need to take this and plug it into our original equation to find our y value. So y equals -5 squared minus 10 times -5 plus 5. All right, so remember, order of operation is parentheses, exponents, multiply, divide, add, subtract. So we're going to do our parentheses. Well, I can't just simplify a -5, so those are done. Exponents. So I need to square this -5. Be careful, this negative is not part of the squaring. It's just going to stay out in front. -5 squared is -5 times -5. So the negatives cancel, and this becomes just 25. All right. Now we're doing our multiplying. So -10 times -5 is +50, and then bring down our +5. All right. Technically, that distributes in -25. And now we're just adding. So 50 plus 5 is 55, minus 25, y is 30. And remember, we are talking about millions of mosquitoes. So we could either write 30 million, million, not with an M. Anyway, you get the idea. N, mosquitoes, something like that. Or you could put all the zeros on there. I think it's safer to put the word, but, you know, say la vie. All right, one more thing we have to talk about, but it's really a non-issue. You probably already know this. So if you want to find the vertex from vertex form, this is super easy. And you're going to say, Mr. Barton, what's vertex form? Vertex form is, you can kind of think about it like transformation form. Transformation form. In that it still has the h and the k unsimplified. You haven't done the squaring of this thing yet. You've left it with the h. What this tells us is the transformations, right? This tells us our horizontal shift. This tells us our vertical shift. And vertical shift. Right, and then A does some stuff, but whatever. It's not important for the vertex. So because it's telling us how far our graph is going to move left and right. Oops, that's not a very good line. Let me try that one more time. There we go. Imagine not drawing a straight line with a line tool. So this is our horizontal and vertical shift. So that tells us how this graph is going to get moved sideways and up and down. What's important about that is it tells us how far the vertex is moved from the origin. So if they give you something in vertex form, it's called vertex form because it tells you the vertex and you don't have to do any work. Let me give you an example. If I give you the function f of x equals -2 x minus 3 squared plus, what's your favorite number? 7. All right. This is our horizontal shift, and this is our vertical shift. So we're going to be going up 7, and we're going to be going left or right. Remember, h is always reversed from what it should be. So if it says negative, we go positive. So we're going right 3. Okay. That means come on, give me my parabola. Our parabola goes 1, 2, 3 to the right, and 1, 2, 3, 4, 5, 6, 7 up. So this vertex is at HK, which is 3, 7. The h value is switched. If it says negative 3, h is positive 3. Remember, it's backwards. Okay, so that's an important thing we're going to want to remember for later. Vertex is at HK. That's our vertex. That's why it's called vertex form. This isn't on your homework, but you're going to need to know it later. So thank me later. All right. As always, if you have questions, don't leave them in the comment section because they're turned off. But you can send me a message on Band and you can email me. So let me know if you need help. If you're some poor kid in like Detroit trying to learn math, I'm sorry you can't email me, but thanks for watching.